What if the world's most powerful manufacturing nation just made a deal that could rewrite the future of energy, and hardly anyone noticed? Behind closed doors, far from press conferences and official announcements, a quiet partnership is taking shape.
China,
Africa, and a fleet of vehicles that could challenge everything we understand about electric power. Self-powered EVs. No charging stations. No fuel imports. And no traditional grid dependency. This isn't a rumor circulating on social media. It's a strategic move grounded in economics, energy security, and long-term geopolitics. For years, China has dominated electric vehicle production. Batteries, supply chains, rare earth minerals, Beijing controls them all. But there's always been one weakness: dependency. Dependency on lithium bottlenecks, charging infrastructure, and energy-intensive grids. As EV adoption explodes, that weakness grows larger. Africa, on the other hand, represents something entirely different. A continent rich not just in resources, but in experimentation. Innovation happening outside legacy systems. Energy concepts unburdened by decades of infrastructure lock-in. And most importantly, engineers and inventors willing to rethink how power itself is generated and sustained. That's where self-powered EV technology enters the story. According to insiders familiar with the arrangement, African manufacturing hubs are being positioned to build next-generation electric vehicles using unconventional energy systems, vehicles designed to dramatically reduce or even eliminate reliance on external charging. These aren't mass-market consumer cars yet. They're pilot fleets, test systems, strategic assets. And their destination? Beijing. Why Africa? Because innovation thrives fastest where there's nothing to dismantle first. No legacy grids to protect. No charging monopolies to preserve. Africa becomes the proving ground, and China becomes the scale machine. A division of roles that could accelerate adoption faster than any Western model ever could. The vehicles themselves are designed to operate as more than transportation. Each EV is a mobile energy unit, managing capture, storage, and regeneration in real time. Energy that would normally be lost through heat, motion, or inefficiency is looped back into the system. The result is a vehicle that draws less, wastes less, and survives longer on minimal input. For Beijing, this isn't about headlines. It's about leverage. Imagine a future where China deploys fleets of vehicles that strain neither the grid nor fuel supply during peak demand. Delivery systems, public transit, military logistics, emergency response, vehicles that keep running even when infrastructure fails. That kind of resilience changes national planning entirely, and it raises uncomfortable questions for the rest of the world. If Africa becomes the manufacturing testbed for self-powered EVs, it won't stay confined to Chinese contracts. Knowledge spreads. Blueprints leak. Engineers adapt. Competing nations will scramble to respond, not with better marketing, but with entirely new energy philosophies. Western automakers may already be behind. Meanwhile, African engineers involved in the project are reportedly gaining something far more valuable than contracts: control. Control over design evolution. Control over localized production. Control over intellectual contribution in a system that has historically excluded them. If this partnership succeeds, it won't just shift power grids. It will shift power dynamics. And as the first prototypes roll out quietly, without press events, without global announcements, the question isn't whether the world will notice. When the first prototype units arrived in Beijing, there were no parades, no press releases, no public test drives. Just engineers, analysts, and policymakers standing quietly around vehicles that represented a future most people weren't prepared to understand yet. Initial testing focused on endurance, not speed, not luxury. How long could these vehicles operate with minimal external input? How well could they manage energy in dense urban environments where motion, heat, and stop-and-go traffic dominate? Early reports suggest performance that challenged conventional benchmarks. Not flawless, but disruptive enough to demand attention. What mattered most wasn't what the vehicles did on day one. It was what they eliminated. Fewer charging cycles, reduced peak load on city grids, minimal reliance on centralized energy supply, In a city the scale of Beijing, even marginal reductions translate into massive strategic gains. What looked like an experiment on paper became a data-driven argument for something much bigger. Behind the scenes, Chinese planners began exploring expansion scenarios. Public transport fleets first, then logistics, then energy-sharing networks where vehicles communicate, redistribute surplus power, and stabilize demand dynamically. The car stops being just a car. It becomes part of an adaptive energy system. And Africa? Africa doesn't fade into the background in this story. It moves to the center. Manufacturing zones tied to this partnership began scaling quietly. Technical schools adjusted curricula. Local suppliers shifted focus. Engineers who once assembled imported technology now found themselves refining systems that hadn't existed anywhere else before. For the first time, production wasn't just about labor, it was about authorship. This changes something fundamental. Knowledge flows no longer move in one direction. Africa isn't receiving finished technology. It's shaping it, iterating it, stress testing it in environments where energy scarcity is real, not theoretical. Every improvement feeds back into the system, tightening the loop between invention and application. Global markets are starting to sense it. Energy analysts notice altered projections. Automakers hesitate on billion-dollar charging investments. Grid operators quietly reevaluate long-term demand forecasts. Nothing public, nothing dramatic, just subtle shifts that signal uncertainty. Because if self-powered EV fleets prove viable at scale, entire assumptions collapse. Energy stops being something you stop for. Infrastructure stops being a prerequisite. Mobility stops being tethered. And power, real power, moves to whoever controls the design logic behind these systems, not the fuels that feed them. What makes this moment dangerous and fascinating at the same time is its silence. No global summit. No announcement. Just momentum building beneath the surface. The kind of momentum that only becomes visible when it's too late to stop. Some experts believe this partnership is a test run for something even larger. Others think it's a hedge, China placing a quiet bet against a future where energy unpredictability becomes the norm. Both interpretations may be true, because this isn't just about Africa and Beijing. It's about preparing for a world where grids fail, supply chains fracture, and mobility becomes survival infrastructure. And if that world arrives sooner than expected, the countries that experimented early won't be the ones scrambling to adapt. What's most striking is how deliberately this entire initiative avoids the spotlight. In an era where breakthroughs are usually announced before they're proven, this one is unfolding in reverse. Evidence first. Scalability second. Visibility last. By the time headlines catch up, the systems may already be embedded too deeply to ignore. Inside Beijing's planning circles, conversations have reportedly shifted. Not about whether self-powered EVs are viable, but where they should be deployed first when energy stress peaks. Cold winters, heat waves, grid overload scenarios. Situations where conventional vehicles become liabilities instead of assets. In those moments, a fleet that sustains itself isn't innovative. It's essential. At the same time, African facilities continue refining designs under conditions that simulation labs can't replicate. Dust, heat, voltage instability, long distances with no support infrastructure. If a system survives there, it survives anywhere. Every field test becomes a filter, stripping away inefficiencies and strengthening what remains. Something subtle begins to emerge from this process: standardization without centralization. Instead of one monolithic design, variations start appearing, adapted for terrain, climate, use case. Urban transit versions, heavy-duty logistics builds, compact utility models, all built on a shared open framework, but tailored locally. The blueprint isn't frozen. It's alive. That flexibility is what alarms traditional energy planners. Because centralized grids depend on predictability, on control, on consumption patterns they can forecast years in advance. But a world filled with semi-autonomous energy nodes, vehicles that generate, store, and redistribute power dynamically, breaks those models entirely. Energy stops flowing top-down. It starts circulating. And once circulation replaces distribution, power, both literal and political, reorganizes itself. There are already signs of friction. Industry lobbyists questioning feasibility. Analysts framing the concept as experimental. Careful language designed to slow interest without openly confronting the data. Not outright rejection, just doubt, sown precisely enough to delay action. Because delay is the only real defense. Once scaling crosses a certain threshold, reversal becomes impossible. Factories convert. Supply chains realign. Human capital migrates. And the cost of staying with legacy systems begins to outweigh the cost of change. That's the tipping point China appears intent on reaching quietly. Not with consumer hype, but with institutional reliance. If public buses, delivery fleets, emergency services begin depending on these systems, removal isn't an option. Policy follows practice. Regulation follows necessity. And what started as a pilot project becomes the baseline. For Africa, the long-term implications may be even more profound. This isn't extraction economics. It's participation economics. Value isn't leaving the continent, it's compounding there. Skills. Design authority. Manufacturing leverage. A generation of engineers growing up not as adopters, but as originators. That changes negotiation tables forever. And as these vehicles continue running, carefully monitored, constantly refined, the silence surrounding them grows louder. Because silence at this scale usually means one thing. Something is being prepared. Not for headlines. And when they do, there will be no grand announcement. Only a quiet realization that the balance has already shifted. By the time analysts begin asking the right questions, fleets will already be in operation. Data will already exist. Performance curves will already favor systems that don't wait for permission from grids or fuel markets. And the countries watching from a distance will face a difficult choice: rebuild from scratch or buy into a system they didn't help design. Because this kind of advantage doesn't announce itself. It accumulates. Inside the partnership, planning has moved beyond vehicles. Conversations now include infrastructure that doesn't look like infrastructure at all. Roads that double as energy data arteries. Parking depots that behave like distributed substations. Cities where mobility isn't a drain on power, but a contributor to it. This is where the idea becomes uncomfortable. In such a system, transportation isn't supported by energy networks. Energy networks emerge from transportation. The act of moving generates stability instead of demand. And once that logic takes hold, everything from urban planning to national security has to be reevaluated. Critics still argue that no vehicle can truly be self-powered. That physics has boundaries, that efficiencies plateau, that losses dominate over time. And they're right to a point. But what this partnership exploits isn't perfection, it's asymmetry. You don't need infinite energy. You need enough independence to outlast failure elsewhere. Even partial autonomy, multiplied across thousands of vehicles, creates resilience most grids can't match. When power plants go offline, when fuel routes fracture, when demand spikes without warning, systems that can sustain themselves even temporarily become the backbone. And backbone systems rarely get dismantled. What's emerging between Africa and Beijing is not a product launch. It's a strategy rehearsal. A test of what happens when energy generation, storage, and mobility blur into a single adaptive layer. A rehearsal for a future where geopolitical power isn't measured by barrels or kilowatts, but by adaptability under stress. Some policymakers understand this already. Others will recognize it too late. Because systems like these don't replace the old world overnight. They wait. They integrate. They collect trust quietly. Until the moment the old system fails. At that moment, the question won't be who invented self-powered EVs. It will be who had them running when nothing else worked. And as this silent alliance continues refining, deploying, and expanding, without headlines, without spectacle, the rest of the world remains focused on yesterday's energy debates. At first, it will look ordinary. Just vehicles doing their jobs. Deliveries arriving on time. Public transport running without disruption. Emergency systems holding steady during outages that would have paralyzed cities just a decade earlier. Nothing flashy. Nothing that screams revolution. That's how the most dangerous transformations take place. Quiet success becomes normalized. Reliability becomes invisible. And by the time comparisons are made, the gap is already too wide to close quickly. Inside China's policy circles, contingency models are reportedly being rewritten. Not replacing the grid, at least not yet, but planning for a future where the grid is no longer the single point of failure. Where mobility becomes redundancy. Where power moves with people instead of being fixed in fragile locations. This thinking reshapes defense, logistics, and disaster response in ways the public will never see directly. And Africa continues to absorb something even more powerful than contracts or capital. Experience. Every iteration teaches what no white paper can. How systems behave when the road degrades. When components overheat. When maintenance must be improvised instead of scheduled. These lessons don't just improve vehicles, they evolve design philosophy. A philosophy grounded in survival, not optimization. That philosophy doesn't stay local for long. As word quietly spreads through engineering communities, interest grows. Delegations arrive. Consultants ask questions that sound harmless, but reveal strategic curiosity. Competing nations begin feasibility studies of their own, not because they believe they can leap ahead, but because they fear falling behind. This is the moment tension enters the equation. Because once multiple powers recognize the same future, cooperation becomes competition. Standards become battlegrounds. Compatibility becomes a diplomatic word for influence. And the open nature of the blueprint, the very thing that empowered innovation, becomes something others attempt to shape, steer, and control. Still, momentum favors those already moving. Factories don't wait for consensus. Engineers don't pause for permission. Systems already deployed don't disappear because a conference disagrees. Practical success outruns debate every time. What began as a quiet energy experiment now edges toward inevitability. Not because it's perfect, but because it works well enough, in enough places, under enough pressure, to be trusted. And once trust forms, especially in moments of crisis, it hardens quickly. The world may continue arguing about energy futures on panels and stages. It may keep investing in massive centralized projects that promise stability years from now. But somewhere else, vehicles will continue moving, generating, adapting, proving something simpler and far more unsettling.